In question number 31, a mutual inductance consists of two coils X and Y, in which 1/4 of the magnetic field produced by X links with Y. The mutual inductance is M. What will be the mutual inductance when Y is used as primary? Here, mutual inductance is same for both the coils, so answer will be M. So option 3 is correct option. In question number 32, the switch K is switched on at t is equals to 0 and the current through the battery flows. We want to find the current at t is equals to 0 and t is equals to infinity. Here the inductor will behave as open circuit at t is equals to 0. As this circuit is open, the current will only flow through the 10 ohm resistance and same current will flow through 20 ohm resistance. So R equivalent will be 10 plus 20, that is 30. So I will be 2 divided by 30, that is 1 by 15 ampere. At t is equals to infinity, the inductor will behave as short circuit. If this inductor is short circuited, this whole combination will be short circuited and R equivalent will only be 20 ohm. So I will be 2 by 20, that is 1 by 10 ampere. So at t is equals to 0, current is 1 by 15, and at t is equals to infinity, at steady state, current is 1 by 10 ampere. So option 1 is correct option. In question number 33, two LR circuits are given with inductance L1 R1 and L2 R2 resistance. Here we have to compare inductance and resistance. For both of them, the current versus time graph is given. From this graph, we can see that maximum current for both of the circuit is same. So maximum current I naught is equals to V by R1 is equals to V by R2. So we can see R1 is equals to R2. Now we know that di by dt is inversely proportional to L. So from that we can write L1 is less than L2. Option 3 is correct option. In question number 34, for the given circuit, we want to find the final current through 30 ohm resistance. Final current, that means current at t is equals to infinity, that is at steady state, and at steady state the inductor will behave as a short circuit. So if we replace this inductor with short circuit, this resistance will also be shorted. So R equivalent in the circuit will only be 30 ohm. So I will be V by R, that is equal to 0.1 ampere. So option 2 is correct option. In question number 35, a coil of wire having finite inductance and resistance has a conducting ring placed coaxially within it. The coil is connected with a battery at time t is equals to 0, so that a time dependent current I1t starts flowing through it. I2t is the current induced in the ring, and B of t is the magnetic field at the axis of the coil due to I1t. We want to find the product I2t, that is induced current, and B of t, that is magnetizing field. Here induced EMF is given by minus of d phi by dt. So E is equals to minus A d by dt of magnetic field, that is mu naught n I1. So E can be given by minus A mu naught n di1 by dt. Now I2 can be given as E by R. So I2 is minus E mu naught N by R di1 by dt. And I1 can be given by I0 into 1 minus e power minus t by tau. If we draw the graph for this, it will have this kind of situation. At particular time I will be maximum, so the graph of I2t and B of t will pass through some maximum value. So option 4 is correct option. In question number 36, for a given AC source, the average EMF during the positive half cycle will depend on. For sinusoidal cycle, E average is given by 2 E naught upon pi. For sinusoidal wave, E average for square wave is E naught. So the average value depends on E naught as well as shape of the wave. So option 3 is correct option. In question number 37, the alternating EMF is given by V is equals to V naught sine omega t. We want to find the instantaneous EMF at t is equals to 1 by 600 second. V naught is given 10 volt, sine of omega is 2 pi f, and f is given 50. So V will be 10 sine of pi by 6. So V will be 5 volt. So option 3 is correct option. In question number 38, the voltage of an AC source is given by 50 sine of 100 pi t into cos of 100 pi t. The peak value we have to find. For that, it should be in standard form. We know that 2 sine theta into cos theta is equals to sine 2 theta. So we can write V is equals to 25 sine of 200 pi t. From this, peak value is 25 volt and frequency is 100 hertz. So option 3 is correct option. In question number 39, we want to find the relation between IRMS and I0. IRMS is given by I0 by root 2. So option 2 is correct option. In question number 40, an alternating voltage of E is equals to 200 root 2 sine of 100 t volt is connected to a condenser of 1 microfarad. We want to find the reading of ammeter. The ammeter will always read the IRMS value. So IRMS will be VRMS upon the impedance, that will be XC. XC is 1 by omega C. Omega is 100 and C is 10 power minus 6. So that will be 10 power 4 ohm. So IRMS is equals to VRMS will be V peak divided by root 2, that will be 200 volt. So IRMS will be 200 divided by 10 power 4. So IRMS will be equal to 20 milliampere. So option 4 is correct option. In question number 41, a transformer steps up an AC voltage from 230 volt to 2300 volt. So primary voltage is 230 volt and secondary voltage is 2300 volt. The number of turns in secondary coils is 1000. We want to find the number of turns in primary side. The transformer ratio is given by NP by NS is equals to EP by ES. We want to find NP, that will be EP divided by ES into NS. So NP will be 100. So option 1 is correct option. In question number 42, a coil of self-inductance 1 upon pi Henry is connected in series with a resistance of 300 ohm. A voltage of 200 volt and frequency 200 Hertz is applied to this combination. We want to find the phase difference between voltage and current. Here phase difference can be given by tan phi is equals to impedance divided by resistance. XL is omega L divided by R. Omega can be written as 2 pi F. F is given 200 into L is 1 by pi divided by resistance is 300. So tan phi will be equal to 4 by 3. So phase difference will be tan inverse 4 by 3. So option 1 is correct option. In question number 43, a 100-kilometer long telegraph wire has capacity of 0.02 microfarad per kilometer. So the capacitance of 100-kilometer long wire will be 2 microfarad. It carries an alternating current of frequency 5 kilohertz. We want to find the value of inductance required so that the impedance is minimum. When Z is minimum, the resonance condition is achieved. So omega will be 1 upon under root LC. Omega is given by 2 pi F is equals to 1 upon under root LC. So L will be 1 upon 4 pi square F square into C. It will be 1 upon 4 pi square F square will be 25 into 10 power 6. Capacitance is 2 microfarad, that is 2 into 10 power minus 6. Simplify this, we will get L is equals to 0.507 millihenry. So option 3 is correct option. In question number 44, for series LCR circuit, the resistance is 10 ohm and the impedance is 20 ohm. We want to find the phase difference between current and voltage. The phase difference can be given by cos phi is equals to R by Z. So cos phi is equals to 1 by 2. So phase difference will be equal to 60 degree. So option 1 is correct option. In question number 45, for an AC circuit, the EMF is given by 200 sine 314t and current is given by sine of 314t plus pi by 3. That means phase difference between EMF and current is pi by 3. We want to find the average power consumed. The average power in AC circuit is given by IRMS into VRMS into cos phi. The IRMS value will be 1 by root 2. VRMS is 200 by root 2 and cos pi by 3. So this will be 100 into cos pi by 3 will be 1 by 2. So power will be 50 watt. So option 4 is correct option. Thank you.